Starting. All right. 31 and 32. 31 says sine of pi over 4 plus x. Now, there are two ways I can approach this. We can approach them using these rules, which we talked about yesterday, is sometimes slower but often works. We can also approach them using the cofunction rules, which we talked about on Tuesday, that are faster if you can figure out how to apply them. I'm going to use the cofunction rule for this problem because it is very fast and easy to use. Let's take a note. To do so, I will remind myself that I take everything inside and think of it like another variable. U, V, W, Y, whatever you want it to be, theta, T. Think of it as one object. According to my cofunction rules, the sine function is equal to cosine of pi over 2 minus that function. This is one of our cofunction rules. Now, in your cofunction rules we talked about in class, both of these were x's. But remember, the variable is just a variable. It can be anything, including a u. So now I've made this conversation. I've taken whatever's inside my sine and just called it something else. Well, according to the cofunction rule, that is equal to pi over 2 minus that thing. So now, I just do a substitution. This means that sine of pi over 4 plus x is equal to cosine of pi over 2 minus whatever u was. So my u in this case is pi over 4 minus x. Now I distribute, pi over 4 plus x. Now I have to distribute and simplify, and then I'm actually just done. It's really nice and simple. Compared to doing it this way. This way we'll still get the same answer, but you have to be very specific on how you do it. It takes a lot more work, is what it does.
Because I did it and I finished it, but I didn't get the answer that they got.
You probably got the reverse of it, right? X minus pi over 4?
Square root 2 over 2, and then sine of x plus cosine of x.
Mm-hmm. So yeah, that version is if you use these rules specifically, you get to that step, and you have to use them in a very specific way. If you want a second, I can show that one too. Okay, so this way, I'll keep going and finish it. So I distribute the negative. This becomes pi over 2 minus pi over 4 minus x, or cosine of pi over 4 minus x.
That's what I got.
That is the solution. That is a solution. Now the book, you'll notice, gives a different solution. And I believe it was, yes, square root 2 over 2 times sine plus cosine. Something weird like that?
Yeah.
If you type that answer and this answer into your graphing calculator, they are the same function. Okay, they are the same function. Now, I will showcase how they got to their answer here in a second. But do note, this is one version of the answer. It's not the version the book gave, but as I said, depending on how you use these functions, you can get to slightly different answers or wildly different answers that end up being the same function. That is why Trig has all these interconnected parts. It's because, what if I want one written as two functions? Well, in the book's version is probably the one I want to use. But what if I want one written as one function? That's the version I want to use. What if I want to turn a sine? Then the original one's the one I want to use. I have so many ways I can rewrite and remold and refold all these pieces together. It just gives me options. Now the book's one approaches it using these functions. So on 31 again, this time using the book's technique, it says we have sine of pi over 4 plus x. It jumps to the top equation and says, okay, we're going to use this equation to get our solution. That would mean I do sine of pi over 4 times cosine of x plus cosine of pi over 4 times sine of x. It then goes to the unit circle and substitutes in both pieces that I have values for, sine of pi over 4 and cosine of pi over 4. Sine of pi over 4 is square root 2 over 2. God bless you, Haley. Cosine of x plus cosine of pi over 4 is also square root 2 over 2 times sine of x. What the book did was it factored out the square root 2 over 2 and wrote the solution. So the book says, okay, factor out square root 2 over 2. What's left behind is cosine x plus sine of x. I believe the book switched the order of these, but that's allowed. You can switch the order of addition specifically. So this is a solution as well. So that means we have now two answers. My answer using the cofunctions, their answer using the addition subtraction functions. They're the same thing. If I graph both these, they are the same. 32, was the other one asked about?
Yeah, I figured it out.
You figured it out? Okay. So imagine 32 has a similar trick to it where I could either use the cofunction rules or I could use the addition subtraction rules. Both should be the correct answer, but only one of them is going to be listed in the back of the book. Okay? Andrew.
Alright, so 16 and 17.
Yes, sir.
You have undefined, like, within there. I didn't do that.
Let's do it. 16 and 17. Let's do 16 first since it's not in the back of the book. 16 says cotangent of pi over 2 minus x. Not cosine. Cotangent of pi over 2 minus x. Right, 16. And it says in the problem too, simplify the given expression. I'm again going to use the tangent function, its cofunction version, to write this problem out. Are you ready? So, there is a direct cofunction that gets you the solution. There's also an indirect cofunction that will get you the solution. I will showcase both very briefly. Here we go. The direct cofunction says, well, this is just the other side of tangent of x. If you look at the list of cofunctions, this is the other side of tangent of x, which means that's my answer. I'm done. If I don't see that, then I can do the same thing I just did on 31. I can rewrite this as a u and then substitute it and see what happens. So now I'm going to do it again. This time, ignore that for a second. I make this my u. So I have cotangent of u. According to my cofunction rules, cotangent of a value is equal to tangent of pi over 2 minus that value. Now I do a substitution. Everywhere I have u, I replace with pi over 2 minus x. So, cotangent of pi over 2 minus x is equal to tangent of pi over 2 minus, everywhere there used to be a u, I replace with pi over 2 minus x, which means I have minus pi over 2 minus x. I get that equation. It's the standard substitution for algebra 1. Now, I simplify by distributing and write my solution. When I distribute, I get tangent of the pi over 2 from the outside minus, distribute the negative becomes pi over 2, double negative makes that plus x. Pi over 2 minus pi over 2 is 0, so that's why I get tangent of x. Did you try to convert the cotangent into 1 over tangent and do one of these?
I changed
That's the
mine
devil.
to
If you do it that way,
sine
it takes so long. So long. I told you the cofunctions are optional, but sometimes useful. Okay? Let's go to lunch.
Well, that was writing.
Yeah.
I did.
With number 16 being done, do you also want to see number 17? Okay. Any other problems with homework? As a reminder, 48 is already done. The video will be posted at 7 o'clock. It's a long problem, so make sure you pay attention to it and look at the steps. There are a lot of steps, but each step is something from Algebra 1. It's either FOILing or distributing or factoring. Like, there's a lot of them. So, today with 48, see what you think about it. It's a good time. Any other questions in the homework? Remember, it is 4 through 51 all, so anything in that group I will do. I'll just stand here and this. Press the block.
And look pretty.
Good.
So wait, the one that took a couple of class grades, is it just complicated or is it just there's that much work to it?
No steps are complicated, but the steps are not the fun steps. You're distributing tangent functions using FOIL.
So it's gonna take the whole page to work this thing out.
It probably took like 3/4 of a page for most of the students yet. It was a fun one. Like I said, no individual step was difficult. It's just when you're FOILing tangent of x
Tedious.
plus tangent of y times 1 minus tangent of x tangent y, when you FOIL that thing out, like, it's nasty. When you combine fractions on that thing, it's nasty. It's just not fun. Okay. I'll be grading Friday nights. I will not grade this section until probably Monday. Just get it as soon as possible. I understand some people may need the weekend because this is the first time we've done such a long part of the section. Just get it done.
All around.
Grade should be updated by the end of the day on Monday, so have a good idea of what your grade is in the class.
Stop figuring.